Hey guys, hope you're doing well and thanks for checking out today's video. Today we're going to talk about chords, tangents, and secants again, but now we're going to talk about the formulas that are associated with them. So just a quick review, I want to go through what chords, tangents, and secants are again, and then we'll talk about these formulas that I've mentioned. So a chord is just a segment that joins 2 points of a circle. So here's an example. Draw 2 points on a circle, connect it, you get a chord. Then obviously the diameter is a special chord that goes right through the center of the circle. So if we said that was the center, a diameter would be this right here. So a diameter is a type of chord. So chords are just lines that go through a circle, 2 points, joined by 2 points. So let's take a look at tangents. So now this is special because it's a line in the plane of a circle, but it only intersects the circle at 1 point. That's the key for a tangent. So we're going to draw a point on the circle, and then just draw a line that intersects that point one time. So something like this, it just touches there, and that's the only time it touches the circle. Another one could be, let's make it here. So draw a point on the circle, draw a line going through that point, and it just touches the circle right there. That's it. So that's a tangent. It intersects the circle at exactly 1 point. Then we talked about secants. This is just a line passing through the 2 points on a circle. So literally it's what it sounds like. It's just a line going through the circle, and you could have the 2 points here, and that would be a secant because it goes through the points. It's similar to a chord, but where a chord would be something like this, where you have a segment going right through with 2 points on the ends. With a secant, you're going to extend those lines. It's going to keep going right on through. So secants really related to chords, but just not a segment, it's just a full line. So now that we've reviewed that, let's get into these formulas that I mentioned. So the first one is called the intersecting chords formula. And it says that if 2 chords intersect in a circle, the product of the lengths of the segments of one chord equal the product of the segments of the other. And what I've done is I've drawn it out so it makes a lot more sense than that confusing example that I just said, the confusing definition. It's just saying that if you have a chord, so we have chord CD, so chord CD you can see is that line right there, and then you also have chord AB. Okay, so that makes sense. Should have capitalized A and B, but whatever. And it's saying if 2 chords intersect, so these do intersect, they intersect right here. It says the product of the lengths of the segments of one chord, so the product of the length of the segments of chord CD, this one right here, the lengths of each segment, so I need to take length C, multiply it by times length D. It says it's equals to the product of the segments of the other one, which is length A times length B. So that's how we get that. And so that's an important one to know, and we'll go through some practice later on and this will make more sense, but this is just an introduction. So that is the intersecting chords formula. Now we have something called the secant formula. And this says that if 2 secant segments, remember secants are lines that go through 2 points, if they are drawn to a circle at the same external point, so that means they meet at the same point right here. So that is the same external point. The product of the length of one secant segment and its external part is equal to the product of the length of the other secant segment and its external part. So the key here is knowing what it means when it says the length of the secant segment and then this external part. So the length of the secant segment is the entire length of the secant. So that's this whole thing. That's where you see C right here. That is this whole distance here. That is the length of the secant segment. And then you have the length of the external part. Well, that's the length of the part outside of the circle. So that's just part D here, and D represents going from the edge of the circle all the way to this external point that they meet at. So that's the difference between the entire segment length and this external part. Oops, I just erased that. I'll just draw it back in for now. So now let's think about, well, what it's saying. It's saying that if I have one secant and they meet at the same external point, it's another product multiplication. So I'm going to take the length of the entire segment, which is C, multiply it by its external part, which is D, and that has to equal the same thing with the other secant. So A is the entire secant length multiplied by B, that external part. Lastly, we have the secant tangent formula. So this says that if a secant and a tangent segment are drawn to a circle from the same external point, so again, same external point, that's this right here, the product of the length of the secant segment and its external part equals the square of the length of the tangent segment. So I can take the entire length of the secant segment So that's what we did last time. That's the B side. Then the external part is C. And then we can take the length from the external point to the circle of the tangent, that's this part right here, and just square it. So A squared equals BC, and that's our formula for the tangent secant formula. So hopefully that makes sense. If you have any questions, I'm sure you do. We're going to have a lot more practice videos. I just wanted to introduce to you guys the formulas here, and you got to write these down, you got to study them, because now we're going to go into practice problems where you need to be able to apply these. Hope this was able to help. Let me know if you have any questions.